Should we do an example? Claim all elementary row operations from a classic linear algebra class come from outer products, the sum of matrices with the identity matrix and the appropriate outer product, which we're going to get there, don't worry. So let's not trip. So this is going to be example 3.3.1, and then just make sure that I'm not sinning here. Really want to do a better job of, yeah, I got 5 minutes, that's plenty of time. We're going to call these the elementary base, we're going to call these the elementary matrices. So let's let the set E sub I, and perhaps we'll call it E sub k. K goes from 1 to 3, and we'll let this be a subset of R3. Represent, I guess we could do it in general, the elementary basis vectors for Rn. We will say that E sub k, if I look at the jth coordinate of this basis vector, we're going to call it 1 if j equals k and 0 otherwise. Right? If n is equal to 3, let's go ahead and take a look. How many basis vectors would I have? So my set would be k goes from 1 to n. Well, what is n in this case? Is this below your intellect? N is 3. I feel like that Katy Perry song right now. Hot and you're cold. You're like leaving me out in the dry here. How many do we have? 3 of them. What size are they? R3. Okay. Now let's take a look at the entry by entry definition of each of these things. So I know that E1 was supposed to be equal to a 3 by 1. And then I wanted to know, what about E1 of 1, 1? Well, question, is j equal to k? Okay, if j is equal to k, what's the entry there? 1. What's everything else? 0. What about E2? Let's see, E2, 1, 1. Is j equal to k? No, so that's 0. What about 2, 1? Can somebody intuit, not like the software, but like the verb, can you intuit what the next one should be? 0, 0, 1. Let's define the matrix units EIK to be equal to EI EK transpose. And this is going to be done in n by n space, because this thing right there was an n by 1. This thing right there was a 1 by n, right? Okay. How many different choices would I have for this case n3? How many choices of I do I have? How many choices of k do I have? Yeah, so in n equal 3, let's go ahead and just rate them off. Let's do 1, 1. So this would be E1, outer product, E1 transpose. How big is E1? 3 by 1. How big is E1 transpose? 1 by 3. The moment I see that this is a 3 by 1 and that's a 1 by 3, how do I know it's an outer product and not an inner product? Outer product on the left has a column vector, on the right has a row vector. Inner product, both of them are same column vectors in the case we looked at. Okay, let's go ahead and just fill out what that matrix unit would be. What is it? First entry, first row, first column. 1 times 1 is 1. First row, second column. First row, third column.
0, 0, 0.
Okay. Should we take a look at E1, 2? What is E1, 2? Well, it would be E1 times E2 transpose. Let's go ahead and write this down till we're blue in the face. How big is E1? It's a 3 by 1. How big is E2 transpose? Yeah, and so this is going to be your challenge. I actually did this for you. So now this is, and I'll stop here, 1, 0, 0. So you now have some homework. Let's go ahead and take a look at the outer product. First entry, row 1, column 1, 0. Row 1, column 2. 1 times 1 is 1. Row 1, column 3, 0. What do you know about everything else? Okay. Please generate, please finish all other matrix units.